All right, let's jump right in. Today we're going to decode something that trips up pretty much every .NET developer at some point. The 3 service lifetimes for dependency injection. You know what I'm talking about. Add Transient, add Scoped, and add Singleton. If you've ever just stared at those wondering what the actual difference is, well, you've come to the right place.
And you know what? You're not alone. This comment from a user on Stack Overflow just hits the nail on the head. It perfectly captures that feeling of frustration. The official definitions for transient and scoped, they sound nearly identical, don't they? But in reality, how they behave couldn't be more different. Our mission today is to clear this up once and for all.
So where does all this confusion come from? It really boils down to that subtle, tiny difference in wording. The official documentation isn't wrong, not technically, but it feels so ambiguous because it assumes you already know what the word request means in 2 totally different contexts.
And that right there, that's the whole ball game. This is the key that unlocks everything. When we say request, are we talking about a code request, like a single line in your controller asking for a service, or are we talking about an entire HTTP request, a user hitting a button in their browser? Getting this one distinction right changes everything.
Okay, to really make this stick, let's forget about code for a minute. We're going to step into the DI cafe. Trust me, this little analogy is going to be our mental model, and it'll make everything else fall into place.
First up, transient services. Think of these as your baristas. Imagine this cafe is run a little inefficiently. Every single time you order a coffee, they hire a brand new barista just for that one drink. You ask for an espresso, you get one barista. A minute later, you want a latte, you get a completely different, brand new barista. A fresh instance for every single little ask.
All right, next we have scoped services. These are like the cashiers. Now, the cashier is assigned to you for your entire visit. From the moment you walk in to ordering your coffee, maybe adding a pastry, you deal with the exact same person. The moment you leave and a new customer walks in, they get their own dedicated cashier. The scope here is your visit, or in the web world, a single HTTP request. And finally, the Singleton. This is the big boss, the shop manager. There is only one. Not one per day, not one per customer. There is one single manager for the entire life of the coffee shop. Every barista, every cashier, every customer, all day, all week, they all talk to the exact same manager. It's one and only one instance, period. So now that we have our coffee shop crew, the barista, the cashier, and the manager, let's connect this analogy directly back to the technical definitions and see how it all lines up.
And this table just lays it all out beautifully. Look at the definitions again. Transient, created every time it is requested, just like ordering a coffee from a new barista. Scoped, created once per client request, just like getting a cashier for your whole visit. The analogy just makes that confusing language crystal clear.
Analogies are fantastic. But seeing is believing, right? Let's look at a quick demo in the code. We're going to track some object IDs, and you'll see exactly how these lifetimes behave in a real app. This is the aha moment. So here's the setup. It's simple. We've got a controller, and that controller depends on another service. Now, inside a single web request, both the controller and that inner service are going to ask for one of each object, one transient, one scoped, and one singleton. We're going to hit this controller twice and just watch what happens to their IDs.
Okay, check this out. The results are in. Just look at the pattern in these IDs. For transient, every single ID is unique. The controller gets one, the service gets a new one. It's a new instance every time. Now look at scoped. Within request 1, the ID is the same for both the controller and the service. But in request 2, it's a new ID. And singleton, well, look at that. It's the exact same idea all the way through. It never changes.
So this just proves it. Our little coffee shop analogy wasn't just a cute story. It lines up perfectly with how the code actually behaves. Within a single customer's visit or one HTTP request, they get a new barista, transient, for each thing they ask for, but they keep the same cashier, scoped, and manager, singleton, the whole time. Between different customers, only the manager stays the same.
Okay, so we've nailed the what and the how. Now for the really important part, the when. When on earth should you actually use each one? Because picking the right lifetime is absolutely critical for your app's performance, how it handles data, and frankly, for avoiding some really nasty bugs. So here's a good rule of thumb. Transient is your go-to, your default.
for services that are really lightweight and don't hold on to any state. Scoped is the hero for anything that needs to maintain state for a single web request. The classic example is a database DB context. You want one context for the entire operation. And Singleton is for those truly global things like a logging service or a caching mechanism. But here's the big warning for singletons. They must be thread safe because literally every part of your app could be hitting that one instance at the same time. Before we wrap this up, there is one final golden rule you absolutely have to know. This will save you from a very sneaky and painful type of bug called a captive dependency. It's what happens when you mix and match these lifetimes the wrong way.
This quote from another Stack Overflow user, Don, just nails it. The rule is simple. A service should never, ever depend on another service that has a shorter lifetime than it does. Let's break down why that's so dangerous.
I love this Russian doll analogy. So picture a long-lived singleton as the biggest, outermost doll. It's going to be around for the entire life of the app. Now, if you put a short-lived scoped doll inside it, what happens? That scoped service gets created just once when the singleton is first created, and then it's trapped. It's held captive inside the singleton, living for as long as the singleton does, not for a single request like it's supposed to. This creates these awful, subtle bugs with stale data that are an absolute nightmare to track down.
So there you have it. Transient, scoped, and singleton, finally decoded. These aren't just random settings you pick. They are powerful tools that directly control the state, the performance, and the stability of your application. So the next time you type services.add, you'll have the full picture. The question is, now that you know the rules of the game, how will you choose?